Hi, I'm Abhiraj Patil. Uh, this is my video for the Cml102 second assignment, in which we have to first of all construct the structures of the given compounds and then simulate the PXRD patterns. So first of all, the first compound that we have is HCTZ or hydrochlorothiazide. As you can see here, I have pasted a snip of or a screenshot of my construction in this report. And so for this particular compound, what I did is I defined it using the OLX2 software. As you can see here, I have used the ellipsoid function as well, so that takes the thermal spreading into account. And so I kept refining it until I found the R factor to be 4.24%, which is acceptable. It showed a green bar on the software, and I stopped when the shift was around 0.0004. As sir mentioned in the video, a shift which is in the third decimal place only is a good enough approximation. So yeah, this is the PXRD pattern, as you can see, for HCTZ. And from the data set that has been provided, it has been mentioned in the data set actually that the parameters are alpha equal to gamma equal to 90 and beta is equals to something around 118 degrees. So it's a monoclinic lattice, and the space group mentioned was P21. Next, what I will do is for the second compound, the first compound had been demonstrated by sir in the video tutorial. So for the second compound, I will just show what the steps I have that I followed were. So as we can see, if we go to the OLX2 software, and this is my final structure for the RMAL compound, and now I'll open the data2 instruction file here, and then I'll click on solve. So while solving, as you can see here, I have used the shell access solver or program. Refining has been done using the OLX2.refining program. So this is like a tentative 3D arrangement of the atoms in the compound. Now, as we can see, sir mentioned in the video that this particular compound was a co-crystal of riluzole and malonic acid. So the chemical structure of riluzole is this. We have a benzene ring here and a 5-membered ring. The whole compound is aromatic, and there is an amine group attached to the carbon between the sulfur and nitrogen groups, and then there is an OCF3 group attached to the benzene ring. So moving to the software, we'll first construct this molecule. As we can see here, there is a 6-membered ring which corresponds to the benzene ring in the molecule. These should be carbon atoms. Now this yellow one is the sulfur atom. Yeah, this yellow one is the sulfur atom. Now again we have a 5-membered ring, right? So opposite to the sulfur atom or adjacent to the carbon atom to which the sulfur is attached, a nitrogen atom is attached. So this here, as you can see, this should be a nitrogen atom. It's the closest we can check in all confirmations as well. This one is out of the plane, so it shouldn't be in the ring, since we have the both two rings are and aromatic, they should be planar. So this should be a nitrogen atom, and the fifth member should be a carbon, and this particular atom, as we can see, it should be a amine group NH2. So this should be nitrogen. Now we at least have the two rings constructed properly. However, I haven't shown the hydrogen atoms yet. Now for the OCF3 group, let me just refine this first. Yeah. So we can see here there are two carbon atoms between. Well, yeah. I mean, there is a one carbon atom between the carbons to which the oxygen and sulfur are attached. So sulfur is attached to this one over here. This should be the carbon in between, and the OCF3 group should be attached to this carbon. Now we can rotate and see that this one is the closest to the this particular carbon, and you click on this and I'll see that it's O. Now we have a CF3 group, right? So first of all, I mean, we can already see that this one is the closest to the oxygen atom, so it should be carbon, and these three should be fluorines. But after we do this, we can confirm that this is correct by checking the bond lengths. For example, this bond length here, it's 1.454. This one here, it's 1.3. No, I have to refine first. Yeah. Right. So this bond length here, it's 1.423. This one here, it's 1.294, and this one here is 1.317. This is 1.370. So I think there should be there is some problem with this. Maybe, I mean, we can see these groups attached over here, which is a little problematic, but it will sort itself out after a while when we construct the malonic acid part. Now, as we can see here, the releasol molecule at least has been constructed, because this is all we need. There is a 6-membered ring, a 5-membered ring containing a sulfur and a nitrogen directly attached to the 6-membered ring. Then we have a carbon atom in between them, and an amine group has to be attached to that carbon atom. Now comes the interesting part. We have to see how malonic acid can be included in this diagram here. So this is the structure for malonic acid. We have 3 carbons, and there is a COH group attached to both ends. We have 3 carbons in total. Now what I can do here is randomly name 2 of the carbons which are 2 of the atoms which are nearby as carbon, and refine this and see what we get. Right. Let's call this one carbon as well, see if a bond is constructed. For now, I'll delete this and refine again. I think there is a carbon over here. Yeah. Okay, so let's say this is a carbon, and since we need a COH group, 2 oxygen atoms should be attached to a carbon atom. If we refine, it will show up like this. Now there should be 3 carbon atoms in total, so that's this. So I click on refine again. Now the carbons at 2 ends should have oxygen atoms attached to them. So again, we will name this as oxygens, and yeah, as we can see here, a malonic acid molecule has been constructed. Now there are a few blobs which can be fixed by showing hydrogen atoms, so I'll just click on this add hydrogen over here. Yeah, and we can see that a few of those blobs have gone. They represent some electron densities. Now this particular blob here may represent the lone pair that's present over the oxygen atom. These as well, they should represent lone pairs present on the chlorine atoms, and this one here, it must represent the lone pair present on the sulfur atom. So again, what we need here is add those thermal fluctuations by simulate those thermal fluctuations by using these ellipsoids. I'll click on this, and yeah, as we can see now, this has been fixed as well. A more desirable thing, which is that this particular malonic acid molecule should be present somewhere around here, somewhere near the near both the amine groups, as you can see here. Now this I couldn't do that because I was just demonstrating in the video. It will take a little bit more time to do carefully, but in my report, when I did it for like the first or second time, I actually got this kind of a structure for riluzole molecule and malonic acid. This is much better because we can see that the dotted lines, first of all, they must represent hydrogen bonding, because this hydrogen atom, the white one here, the small one, there's a dotted line from here to the red one. The red one is an oxygen atom. So this is probably hydrogen bonding. Both of these have 2 lone pairs, and here as well we can see there is a dotted red line. So yeah, that's much more desirable. Now so after constructing this, I should open the Vesta software. So Vesta, right, I'll open this and simulate the PXRD pattern for data 2. As we can see here, a ZIP file appears after we refine it using the acta command here. That must have been the ZIP file for my previous construction. Yeah, so this is what it looks like, and Now we click on utilities and go to the powder diffraction pattern construction. Click on calculate and it plots over here. So this is the PXRD pattern for RML. I'll close all these windows now. Yeah. So the PXRD pattern has been shown over here. I have attached it. According to the data provided, this co-crystal crystallizes in the space group in a monoclinic lattice as well. However, the space group is P21/C, unlike this one where the space group was just P21. We can see the, we could see the space group as well in Vesta. Let me open it again. Zip file, sorry. Yeah. It can be visualized here. This is a monoclinic lattice and centrosymmetric, as you can see. Next, we have Riluzole orthophosphoric acid. This was a little more easier to construct than RMAL because the orthophosphoric acid appears nearby the nitrogen atoms every time, so that I don't know why, but yeah. This is the structure for the co-crystal, I mean one unit of the co-crystal maybe, and this is the PXRD pattern that I simulated. These blobs, I don't know why they appear, the brown ones. Maybe they do represent the lone pairs, that's my only guess, but I don't know if it's correct. Now I'll attach the link to this video below. Thank you.